Okay friends, Assalamu alaikum warahmatullah. So welcome to this demonstration video in which we shall demonstrate the subgroup analysis, three algorithms for the subgroup analysis, two basically. The one we have already gone through, which is the attribute based grouping. So we shall demonstrate how we do it in ORA Lite. So this is the network, institutional financial institutions. This is the same network we used in one of the labs earlier. So we have 11 banks and there are interbank loans which are there. So if we go to the node set, so we have tier, we have assets, zone and leverage ratios for all these banks, and interbank loans, we see that it's a binary network. So coming back over here, we can see it's a symmetrized network and there are no self loops. Now keep in mind that if there are self loops, it's always better to actually use this option, so the system will automatically eliminate any self loops, if any, right? Because in the subgroup analysis, sometimes the self loops actually create some sort of conflicts in the sense that the densities will be reported differently. In one of the tables, the density will be reported including the subgroup, including the self loop, and in another table the density will be reported without the self loop. So it is always advisable to avoid the self loops until and unless contextually it is something that is important. So the links are always binary and it has been symmetrized, it has been checked. It means it was initially an undirected network, but somehow we have symmetrized it and it has been made an undirected network. Previously it was a directed network. So this is the way we can symmetrize a network, we can remove the self loops, and we can binarize the network also if it is a weighted network. Anyway, so let's visualize it. A bug in the software usually does not work. Visualization does not work in the first instance, so we have to use it twice, as you see. So let's close it, call it again, visualize the network. And you can see that this is the network we were talking about. So node appearance, we want to change the node color by means of Newman grouping. So you see over here we have used this color nodes by attribute or measure. Now we are going to use color nodes by Newman grouping. So you see there are some other options as well, color nodes by component, makes sense, and there are a few more algorithms, dense subgroups, Concor algorithm we will do, Newman grouping we will do, and there are a couple of two more algorithms which we have not discussed, some sort of advanced level algorithm. So anyway, I push the Newman grouping and it says that Newman modularity is 0.35, a sort of moderate modularity. 0.35 means yes, there are modules do exist. And okay, and you see there are three subgroups identified, right? This is group 1 with blue color, group 2 with red color, and group 3 with green color. So this is how the Newman the system has actually made three subgroups based on Newman algorithm, based on the pattern of connections among the nodes. So one thing important to note over here is that now if I go to the node set, there is a new feature, Newman grouping, right? So automatically, as soon as we did the Newman grouping coloring in the visualization, the system added a Newman group. So F1 for example is now in group 1, F3 is also in group 1, F6 is in group 1, F9 is group 1. Similarly group 2 and group 3 has already been coded. So now let's come here again. Now I want to color by Concor grouping. So Concor grouping, and I want to keep the split 1, it means 2 groups. I can keep the split at 2, it means 4 groups, maximum 4 groups. So the system will first split the network in 2 based on the concurrent correlation, and with each of those two sets of nodes networks, the system will further split it in 2 and see if a significant group exists. So a maximum of 4 subgroups can emerge. So you see we have again 3 subgroups. So the red ones, right, So these are the same, right? The red ones are same, because in the Concor grouping it isn't necessary to be connected. The nodes do not need to be connected. Their structural equivalence or connection pattern counts. So we have three groups emerging. In group 1 there are almost 6 nodes. In group 2 there are 4 nodes. In group 3 there is just 1 node. Again, if we go to the node set, we see that the Concor group has been added over here, right? So F1 is group 1 actually, right? So this F1 was actually group 1, not group 3, and then group 2 and group 3. So this was the visualization part of the grouping, only grouping. We have not yet analyzed the subgroups. So in the next video we shall see how do we generate the report and analyze and generate some matrices.